Good afternoon, everybody, and welcome to our webinar on Kubernetes Architecture. My name is Ross Beard. I'm here with Shadowsoft and really excited to host you today. This is a really interesting topic because over the last 10 years, Kubernetes has really moved through the technology adoption lifecycle. In fact, in 2021, the CNCF Foundation reported that 96% of organizations are either using or evaluating Kubernetes. But Kubernetes adoption is not easy, as we will learn today. And over the last 8 years, we've seen many organizations make some big mistakes, and we've also seen many organizations innovate in amazing ways, helping them gain an edge over competition. So housekeeping, we are recording this so that folks can watch this that couldn't make it to the live webinar. We encourage any questions and interaction throughout the presentation. So if you've got questions for Derek, feel free to raise your hand and we can address them. We want to try and keep it as engaging and as interactive as possible. So on that note, I want to introduce Derek Sutherland. Derek leads Shadowsoft's Kubernetes practice, where he's been lucky enough to work with 50 plus organizations, helping them design, adopt, manage best-in-class Kubernetes environments. Derek holds a master's degree in cybersecurity and dual bachelor's degree in computer science and security. And he has 15 years of technology experience, specifically focused on software engineering, security, performance optimization, automation, cloud computing, and information assurance. So on that note, I'm going to hand it over to you, Derek, and I'll pull up the slides.
Thanks. Nice to meet everybody. For those of you on the line who don't know me, Ross did a wonderful job of introducing me, but for some background and context on the Kubernetes side of things, yes, I've used Kubernetes with 50 different clients, probably a little more than that. I've actually been using Kubernetes for a decade. My first experience with containers was with OpenShift 2, which wasn't even Kubernetes yet. It was LXC based, pure LXC. They actually called the concepts of containers cartridges and gears. This is before Docker became prevalent and before anyone really knew about it, when people are still using Solaris zones. I was working for the DoD at the time, and they were a customer of OpenShift right when Red Hat first, and for those who didn't know, Red Hat actually acquired OpenShift as a product. It was built by a different company, they acquired it, and then about a year and a half later, they refactored it because Docker came out, Kubernetes came out, they realized that was the future, and so they refactored it and started going in that direction. So that was my first endeavor in it, and again, that was about 10 years ago. Since then, I've used Rancher, EKS, AKS, GKE, K3S, Micro K8s, even what used to be called Juju, but is now called Charmed by Canonical. I've used pretty much every Kubernetes distribution that is major in the space right now. And in terms of Kubernetes, that has given me kind of a historical look at the way things have grown. Things have changed, and it's not only just applied for Kubernetes in general, but even how customers go throughout their journey of leveraging it and using it. So I'll be able to talk to all that history. I'll be able to talk to all those kind of nitnoid details of what that looks like. And then we'll walk you guys through kind of the overall concepts of what we think is important in the space to be considering when you start doing things like an architecture assessment. So with that, we'll probably jump into the slides. So the first thing I'm going to say is most people, when they start playing with Kubernetes, they don't know what they're necessarily getting themselves into. They have a preconceived notion. There's a lot of buzzwords around it. Oh, people will call it a platform as a service. That's not really true. Some people will say that they're re-platforming their stuff onto Kubernetes, and in a way that's true. But it's all with the lens that you take and the visual aspect of your mind of how you look at Kubernetes that's going to define how your journey extends and how successful you're going to be. The first big thing in terms of this is people don't know where to get started. Sometimes organizations will start on the infrastructure side of the house, and they'll go, we want to use Kubernetes because we're trying to automate the way we elastically scale, without understanding the implications that has on the development team. Sometimes the development team starts kind of on the greenfield side of things, they might start building apps in containers and putting them in Kubernetes locally. Maybe they're using K3s on their laptop or something, and they start building some acumen around it, and they want the organization to expand that way. Other times it's top-down pressure. Someone hears Kubernetes is the next best thing, and so the organization has to go in that direction. There's not necessarily a wrong reason for why you started, but there definitely are wrong reasons for why you continue to use it. And also there's very right reasons for why you should be using it. The first thing I will say is, in terms of that, we look at Kubernetes because of the way it's grown over time is it's really an operating system for a software-defined data center. What I mean by that is, and this is very important, everything from software-defined storage, networking, service discovery, resource allocation, everything you can think of in terms of a data center falls into Kubernetes, but it's all software defined. And so thinking it with that kind of hat makes you have a certain type of mindset when it comes to approaching it. If we're used to traditional data centers, whether that be on-premise and you're using something like VMware, right, for what you're using to run your actual stuff, maybe you're running on bare metal, even when you virtualize a lot of those components, there's still a high degree of management that has to happen to some degree manually. Provisioning of machines, live migration of machines, how you take snapshots of things, stuff like that. What Kubernetes really offers you is a way to automate the orchestration of everything soup to nuts once the cluster is created inside the confines of that given cluster. Now, with that being said, because all of that is software defined and all of that is orchestrated and automated, there's a high degree of confusion about how do I take things in the old world and put them into this new world. And that's where like the expertise fall down happens, right? We start looking at Kubernetes and going, this is so different. I don't know how this compares to the old world. And I would say it's even a bigger switch than say something like going from a car that was carburetor based to a Tesla, right? Like the maintenance and management of those cars, they are wildly different. But still, when you're driving the car, you're still driving a car. So that at the end of the day, I think is an easier jump for a lot of people than Kubernetes, because the way Kubernetes orchestrates and runs your workloads is entirely different compared to how it used to. And I'll give you an example of that. So if you're used to running a web server, let's just say it's WordPress in a virtual machine or something similar, that machine is going to stay there for a very long period of time. It could be there for weeks, it could be there for months, it could be there for years. And maybe it gets power cycled every so often or updated or what have you, right? But the juxtaposition of what it's doing is always there and it's always the same. So IP addresses don't change very frequently. You don't have to manage firewall rules constantly, things like that, right? That's the way old things work. In the Kubernetes world, you have these little components called pods. And pods essentially are one or more containers that always have to be glued at the hip together. They're going to move from one machine to another. When they go to orchestrate and they're starting to move from one machine to another, they're going to do that for a number of reasons. Maybe one machine ran out of compute, and so that workload has to shift to somewhere else. Maybe a machine needed to be updated, and so that workload needs to shift somewhere else. Maybe we had some things like an environment crashing and it had to move somewhere else, right? In terms of that, these lifecycle changes happen very, very, very quickly, and they happen all the time. So when you think from a developer perspective, if you're writing code where you're relying on IP addresses, or you're relying on a certain way that storage works, or the way that customers are going to remain connected to your system, all of those things change when you go to Kubernetes, because a service can go up and down very quickly. It can get moved from one node to another. The IP address range is going to change. All things are way different, but they're orchestrated automatically. This isn't a bad thing. It's actually extremely powerful, and it's a very good thing. But if you go into it with the mindset of, I'm just going to take something that lived in the old traditional virtualization world and drop it in here, and it's going to magically scale, you're going in with the wrong mindset, right? You need to be thinking about how this world changes the way that you write code, the way you deploy code, the way you develop across the board, even architecturally, and even how you manage security. Everything is going to change in that regard. So it's a very big shift, and it makes people very afraid We're not going to have the expertise. We're not going to be able to go here. It's way too complicated. Is Kubernetes complicated? Sure. In some ways you can say it is. But what I will say is more important to recognize the fact is it's no more complicated than virtual machine technology is. It's just different. So what's actually complicated about it is it's not what you're normally used to. And so it takes time to learn the way things operate now and get your whole team built up around it. And how those things move and interact and how they orchestrate when you start talking about multiple data centers or multiple Kubernetes clusters, especially as they scale out, is going to get wildly different. And so we like usually with our customers to kind of go through boilerplate. Let's talk about what Kubernetes is. Let's talk about what it does, how it's different from what you're used to doing, and then slowly start teaching your engineers on the infrastructure side, security side, and development side, how this is going to impact you in different ways so you can be properly placed for the future, if that makes sense. Next slide, please. So this initially, after that conversation really happens, starts with three, maybe more, but I would say three different kind of design directions. And it's funny because these design directions are actually the history for how Kubernetes has, from a thought leadership perspective at advanced companies, changed over time. When Kubernetes first came out, it was large data centers that were software defined, and there were very few of them. So this is the same behavior we see when new customers start to adopt Kubernetes. The way that we look at it is many people go, I'm just going to take everything I've been doing and just move it into Kubernetes. Sure, I'm going to refactor my code base, but I'm still going to operate on the same basis principles. And what I mean by that is traditional web apps, web services, things like that, they just want to start hosting them in Kubernetes and let them scale more effectively. When you go into this kind of mindset, the reason that ends up happening first is because it's a path of least resistance to go from what I'm traditionally doing to this new model of doing things. The reason you're doing it, though, is because, again, that kind of elasticity, you get API unification across different environments, dev and pre-prod, prod, everything looks consistently the same, which is good for when it comes to disaster recovery and repeatability, right? What that literally looks like, though, is one or two Kubernetes clusters per different environment type. By environment type, I mean dev, test, QA, pre-prod, prod, right? So we'd go into a customer, they're new to Kubernetes, and this is, again, was what everybody was doing because everybody was new to Kubernetes 10 years ago. They'd go, we have one cluster for dev, one cluster for QA, one cluster for pre-prod, and maybe a prod cluster and a DR cluster, right, for failover purposes. In terms of that, these clusters were really large. And again, they're software-defined data centers. So they're just looking at how can I take my normal business practice and move it into Kubernetes by, well, refactoring and making sure that I'm running in there efficiently. Now, as time has progressed, the use cases and the ways you use Kubernetes has also evolved to go from just these large software-defined Kubernetes cluster data centers to going, how can I get the same API unification that I get with Kubernetes, but I want to be as close to my customer as humanly possible, or my end user as humanly possible. And this is where different levels of edge come into play. So you're looking at what we'd call like near edge or far edge, and et cetera, right? Which is the idea of like, let's say I'm a transportation company and I'm moving goods. You might go, the websites that we host, we have a pre-prod, prod, and dev, test, QA clusters for that. But maybe we have warehouses. And so that would be kind of a far edge, or I'm sorry, a near edge, where we would go, this is kind of a small edge data center that's just for that warehouse. So any apps that are going to be hosted for that warehouse, instead of being hosted remotely in a different data center, they're going to be hosted in a Kubernetes cluster living inside of that physical warehouse. And then they take it a step further for like really close to the customer edge, which is like, I want to run a Kubernetes cluster on maybe at like, if you're having a train station where a train's docking, you might have a Kubernetes cluster that's right up to where the goods are going to get removed from a forklift and onto the train. So that way, again, there's no latency to have to reach out over the internet for those resources to get accessed. They're getting access to resources in a cluster very local to where an action is occurring. I mean, going a step further, this is like Kubernetes clusters that are running in point stores. Like if you're not an e-commerce, but a retail store, like a Dollar General, or if you're somebody like a racetrack and you want to run it inside of like your actual gas station, right? That would be really close to your customer. But you can imagine the more clusters you have and the more disparately they're separated, the more complicated it gets. So everyone goes to that world for the purposes of being close to their customer. But obviously, if I'm doing the traditional way versus doing the edge play way, that's going to ultimately impact design decisions, product selections, how pricing models scale, how we're going to be able to orchestrate and manage those workloads as they go out throughout these different environments. I mean, it's going to change all of that stuff, right? Which is the reason why we want to talk about all these different ways you can use Kubernetes as we're going through ultimately our architecture map for kind of figuring out framework-wise how this is going to build and scale. Now, the way things are getting as time moves forward, though, is even more unique. So if those are kind of the more traditional way, traditional web apps, large clusters, then edge, which is kind of the new thing right now. We have some people even doing more, I would say, bleeding edge things with Kubernetes, which is using Kubernetes as a way to control cost and, make better security decisions, disaster recovery decisions. The idea behind this being, if I have a Kubernetes cluster, say in US East in Amazon, and US East in Azure, and US East in GCP, I can actually build a practice where I could move a workload from one cluster in Amazon to another cluster in Azure and to another one in Google's clouds platform, right? In near real time, reducing my migration costs, reducing the ability for me to get environments stood back up, all because everything is unified from a software-defined perspective. I can link those clusters up from a software-defined storage perspective, link them up from a networking perspective so they can intercommunicate with one another. This lets you be able to be what we call infrastructure agile, where you can move at any time to any environment that you want to, whether it be for DR reasons. Maybe it's because the bills in Amazon got too expensive and you want to move to Google or Azure or vice versa. Or maybe it's because an environment got broken into and you're trying to get away from those environments. That's like the most bleeding edge we're seeing Kubernetes for right now. And it's really starting to grow. But again, it's kind of this stepwise function of where you're at in your journey. How are you seeing Kubernetes get used, for you now, 18 months now, 3 years from now, right? And then how is that going to impact your design strategy from tool selection, workforce management, etc.?
Hey, Derek, jumping in here with a question. What's the biggest mistake you see customers make when it comes to their architecture?
There's a lot of them. The biggest one that's probably most predominant, especially in organizations, that are budgetarily controlled. Maybe they're not small and bleeding edge and they don't have VC, right? They have a traditional CFO, traditional budget system. They'll go and start making design decisions. Maybe they go, we're going to use OpenShift, or we're going to use Rancher, or we're going to use EKS Anywhere, right? They make a decision on, this is the version of Kubernetes we're going to use. And when they go to do that, they haven't thought about the vision for how they're going to use Kubernetes yet. And they haven't thought about the other tools they're going to need to use and buy. So they might want to get a storage solution like Longhorn or Portworx. They might want to get a security solution like NuVector or Sysdig, Aquasec, right? They might want to get a Git hosting software that has a CI/CD management tool like GitLab CI or something similar, right? When they do this, if they go, we're going with OpenShift full board, we're going with Rancher full board. If they hadn't thought about the design decision for how they're going to use Kubernetes, they don't know how the pricing model of that product scales and how that pricing model is going to interrelate to the other products they buy. This is what I mean. If you use, let's just say, Dynatrace for monitoring, Dynatrace charges you per node with an I think it's 8 gigs of RAM maximum per node for them to count as one node unit for Dynatrace, okay? OpenShift charges by core for worker nodes, okay? And GitLab CI charges by user. So how do those pricing models scale, and where does the budget for each of those things come from? Ultimately, in combination with whatever model you're going to use for how you're going to use Kubernetes. If you're not thinking about things big picture like that, you don't know how your pricing model is going to scale to have confidence in good conversations with your CFO up front and your procurement team to make sure that you're budgeting for things properly in the future. That's probably the biggest red flag, and it happens a lot more than you think, actually. So, yeah, that's probably the best way to put it.
Interesting.
Now, in terms of the way that we usually start assessments, we start them with what we call our architecture framework. And you guys that are on the line, I'm sure have already seen, and if not, it'll be shared with you later, kind of like a little snapshot of some of the questions that we start to ask, but the laundry list that we ask is a lot more. I'll kind of go through some of those kind of questions with you guys to give you a feel for what this conversation dialogue should look like. But I want you to be thinking and remembering what we do question-wise highly depends upon what your use case is and what your experience is around Kubernetes. For example, if we have customers come to us, they're new to Kubernetes, and their assessment's really about figuring out what the path for the future is going to look like. We have other customers that come to us with their Kubernetes environment being broken, and they ask us to evaluate what they have currently and pick a path to the future to make sure these types of things don't happen again. And the third one is we have customers come to us and go, we have a new leadership team, and they want to know what we have and why we made the design decisions we have. So all of those different lenses affect the questions because it affects where you are on your journey and how you're going to perceive the questions we're going to ask and how you're ultimately going to be able to best answer those questions. But we start off with this architecture framework, and the questions I really break them out into these different subcategories. So these questions by no stretch are exhaustive. And what I will say is we have separate questions for separate key areas in association with architecture. Now, there's other sections we go into, like, so if you want to talk about high level, we have our architecture set of questions. We have our security set of questions. We have our application set of questions for workloads. We have our disaster recovery and backup and all those kinds of things. But if we're talking the very first, like, getting started style of things, it starts with that architecture framework map. Those questions are broken up into key areas. The first of which is, what is your engineering team's organization built around when it comes to Kubernetes? What I mean by that is, how do you break up your engineering working units from an environment perspective? Development, operations, do you have DevOps and security? We want to know how your teams interact with each other, because that's going to impact communication styles, how things get revved up. Like, if you don't have your own security team and security is kind of on everybody, then it comes up organically. But sometimes the security team in an organization will be completely policy driven, and they don't really understand technology so much as they understand what needs to be done to meet HIPAA or PCI or FIPS compliance, right? And they just need to be informed of how they're going to do that in this world. So we want to know those kinds of things. We also want to know, how are your engineering units broken up? So let's say you have a dev and ops, a DevOps, a sec team. Is that the end of your organization units? Or do you go, well, we're a bank, and so part of our company has all of those grouping units for one set of projects. And then there's another set of all of those groups, dev, operations, DevOps, security, for another set of application projects, right? We want to understand that too, because it lets us know ultimately how things get adopted, how things are learned throughout the organization, how they're going to grow. We start thinking about, what do communication patterns look like? We ask questions about, how do you collaborate? Are you extremely siloed? Things like that. As we kind of go through the process of figuring out what your project communication kind of adoption strategies look like, then we can start talking about, how do you see Kubernetes getting used for you? Is it going to be used for data science and machine learning workloads? Is it going to be used for web apps and web services that need to be hosted in a kind of, not offshore is the wrong word, in a co-located data center, like in the cloud, right? Or does it need to be at the edge like we talked about before? With that, we start looking at questions around Kubernetes cluster design. Have you selected a Kubernetes distribution yet? Is it RKE, RKE2? Is it OpenShift? Is it EKS, right? What version of the Kubernetes API are you planning or are you using? You know, you on 123, or you on 119? Those kind of questions matter because a lot of things get deprecated and added all the time to the Kubernetes API. So it's really important to understand stuff like that. What's the bottom line infrastructure? Are you going to be on Raspberry Pis? Are you going to be in the cloud? Which cloud are you going to be in? Are you going to be in vSphere? Are you going to be bare metal and you want to leverage KubeVirt for part of your decision, right? How are the clusters going to be separated? Now, let me just start off by saying this. Not all these questions, when you start going into them, should be answered with definitive answers immediately. They should be thought about in terms of, this is maybe where we're leaning. We haven't made a necessary answer yet or design decision yet, unless there's some things that are non-negotiable for some reason. And the reason for that is because you may find something you were thinking of doing won't scale for you. Again, going back to the financials, for a financial reason or for a hardware consumption reason. Like some customers will go, ideally, we want a dev, test, QA, pre-prod, and prod cluster for every project unit in our organization. But then they realize that the Kubernetes distribution and the storage solutions they've picked don't scale well in that way, not from a technological perspective, but from a cost perspective. Oh, we're paying per node. And every time we spin up a new cluster, we have to have 3 control plane nodes in addition to our compute nodes. Oh, that's going to get expensive, right? So sometimes then you go, okay, well, we'll say there's going to be 1 dev cluster for all of our working groups. Maybe we'll put dev and test into different namespaces in the same cluster. I don't always agree with that for certain things, but in other things, it's okay rationale-wise. It depends. So like dev and test, maybe you can intermingle, but you wouldn't want to intermingle pre-prod and prod in the same cluster, for example. So there's certain areas where you're going to want to make design decisions and considerations based upon what you can afford and also what makes sense from a workload segmentation perspective. You want to start thinking about how many nodes are going to be in each cluster, again, for scale reasons, as well as how you're going to distribute workloads from a high availability perspective. How are you going to break clusters up from a availability zone or power separation? So that way you make sure that failover is actually possible. What is the network architecture layout going to look like for everything? So a lot of customers think, I'm just going to have a Kubernetes cluster straddle 2 different data centers that are co-located. Is that feasible? Yes, kind of. If you use something like Calico and you BGP peer networks together, is it a good idea though? No. And that's from lots of experience of finding how those things fall over on their face and how hard it is to do things like updates and whatnot. So I say all these things to say there's certain questions you're going to ask yourself that are really convoluted and other ones that will be very straightforward. Things like, do you have DHCP enabled in your environment, or is all IP addresses going to be static? You might go, well, what does that matter? Well, if you're going to hyperscale and just be able to add nodes horizontally as needed, it's really helpful if DHCP is enabled. If you don't, you have to statically allocate IP addresses. You're going to want to take that into consideration when you're selecting your Kubernetes distribution to know it's going to be able to work for you. And then you're going to have to think about that in terms of automation, right? Which for that example, how are you automating workloads, or not workload, I'm sorry, node distribution? Are you going to use Terraform or Ansible? Or are you going to use HandJam scripts? Are you going to kickstart servers because you're bare metal? You're going to want to be thinking about these things up front. Then we start getting into like workloads from an application perspective. And again, I can't say this enough. These questions that we're asking they're not meant to be in this first conversation you have about architecture exhaustive. They're meant to be boilerplate deep enough, but not super deep. So that way you can start understanding where the conversation should ultimately go as you go through each phase of an assessment. So in terms of like application workloads, we're not going to go down in the architecture assessment for Kubernetes. What's the languages you're using, right? Or how long have your developers been, programming for Kubernetes? What is their background? Do they have multiple programming? That stuff comes later. The things you want to think of now are, what are the types of workloads? Are they web apps, web services? Are they REST or SOAP based? Are we going to put databases in there? Are they SQL or non-SQL, right? Kind of higher level concepts, as well as how do you plan to segment workloads from a protection perspective? So if a workload, because it's not like a virtual machine, right? where if a workload gets overused consumption-wise for memory and CPU, in a virtual machine, it's isolated in that virtual machine. In Kubernetes, it could knock out another workload on the same node. So how are you going to distribute nodes to make sure that things run safely and securely in your environment as you scale? You want to think about, again, things from kind of a high-level perspective. How are you going to get traffic into the cluster? How are you planning on getting it egressed out? Are there things like proxies that need to be taken into consideration? Do you have existing CI/CD tools? Do those tools marry up to Kubernetes, right? Or are they things like Jenkins, in which case you can use them for Kubernetes, but they're not purpose-built, and therefore they might lack a lot of features that you would want, say, things like state management from a continuous delivery perspective. And then the last thing you have to think about, again, early and often is, what are our storage requirements going to look like for workloads? Is everything going to be ephemeral and we're not going to have to worry about storage? Are we going to have stuff that's going to require file system storage, or do we need block storage? And in which case, what does backup and disaster recovery, not just for the workloads, but for the storage look like? How are we going to document it and make sure we're safe? And then again, the last probably high level points would be things like, from a security perspective, what are our compliancy requirements? What does our security team expect of us? Do we need an intrusion detection system in place? Does the intrusion detection system we're using work for Kubernetes? And even if it says it does it really? And what I mean by that is, you might go to a company like, I'll use an example, Palo Alto. They have tons of different solutions for a bunch of different security things regarding pretty much everything traditionally. And they claimed for quite a long time that they were purpose-built also for Kubernetes. Fast forward to, I think, about a year and a half ago, they bought a solution that specifically does Kubernetes security, because they knew, despite the fact that they could plug and play with Kubernetes, they weren't efficiently designed for that world, right? So you want to ask the tough questions. Do the tools that we have marry up? And how are we going to facilitate our security requirements? Again, not getting into the weeds, but if we're PCI compliant, does a solution that we're leveraging from Kubernetes give us PCI compliance? Or do we have to do something in addition to that? Things we need to be thinking about as we move forward throughout this journey. So those are the kind of questions we usually ask in the architecture assessment side of things. After that, again, we start in like follow-on meetings talking about things like more in-depth specifics around security, more in-depth specifics around backup and recovery, because backup and recovery, there's a lot of nitty details, configuration information, spinning up of new clusters, getting workloads redeployed, storage requirements, all that kind of stuff. And then for languages, what are the programming languages we're leveraging? Do they fit in this world? What do our apps look like? Do we need to refactor? There's billions of questions, and it can take quite a long time and seem overwhelming. But that's why we ultimately try and ask exhaustive questions in this way and really start with the boilerplate stuff that's necessary to drive the conversation forward.
Thanks, Derek.
Yeah.
We'll just want to make sure that anyone that hasn't downloaded the architecture map, I popped a link to the file in the chat, and you'll see it looks, something like this. Oh, a little blurry. So we suggest downloading it, printing it out. So thinking through those questions. And if you've got to the point where you've filled it out and you've got some questions for Derek, or you want to sort of run your answers by him, get some feedback, we do have that as an option where Derek can sit down with you for 30 minutes, hear a little bit more about what you're looking to do, and you can ask him some questions. So if you are interested, let me know in the chat here, or send me an email as a follow-up, and we can help get that scheduled for you. So we're now at question time. I have a couple of questions to kick us off, and others, feel free to add your questions to the chat. First question for you, Derek. When working with customers, what do you see them telling you that they wish they had known? What had they wished they had known prior to starting their Kubernetes journey?
It's an interesting question. I would say the biggest thing, the people I think of when you ask what they wish they would know, are the people that come to us with fires. People go in with a preconceived notion a lot of times that Kubernetes is the disaster recovery solution, in the sense that when a workload goes down, and this is true, Kubernetes will rescale it back up. But they didn't think about what happens when Kubernetes goes down. And how do I get my cluster back online? How do I get my workloads back? So that would be thing number one. But playing into that same mindset, I would say kind of the things that seem like they would be traditionally solved for maybe aren't, because of the nature of how things are different. An example of that's like, we had a customer who was running a Jenkins pipeline against a production cluster to deploy workloads. When I say production, I don't mean production like client facing, but production in the sense that like they had people actively using these workloads throughout their organization. Think of it like a pre-prod environment that people are actively working in, and if it stops, then people can't do their job, right? They had, and this is kind of where it goes into like, understanding Kubernetes is really important to make sure you're successful. Their CI workload, they were running, I believe it was EKS in AWS, and they had Jenkins. They ran this pipeline that would spin up a workload in a Kubernetes cluster, and it would create an NFS server using Amazon EFS. And midway through the CI job, the program would run a bunch of QA to make sure that it's functioning properly from like a testbed perspective. And when it was done, it would delete that workload and remove the NFS share. Now, the problem was the order of operations. They deleted the NFS share first before deleting the workload. Now, for those on the phone that aren't familiar with the way Linux works, and containers in Kubernetes are essentially an isolated Linux process. If you have a system that's running, that's talking to NFS, and it's a hard mount, and the NFS server goes away, the file system will lock up for the entire computer that's running that Linux process, waiting for that NFS server to come back. So if you run like a df command, or you run like any command on the box involving the file system, it'll just sit forever and wait. So long story short, somebody was running this CI/CD job, and they were doing it multiple times a day, and nodes would get in this weird state where all the workloads on them would get stuck in pending. They could no longer access their file systems. New workloads wouldn't deploy to them. Old workloads wouldn't get off. And they thought something was wrong with Kubernetes. So they would restart the nodes and everything would go back to normal. So they were like, it's got to be a bug. It's got to be a bug. They were dealing with this for like 3 or 4 months. And so we came in, we're doing an assessment of things, and then saw what they were doing. And we're like, the problem is not the Kubernetes distro, and it's not a bug in Kubernetes. The problem is you're deleting an NFS share while a workload is still actively talking to it. And this is where I say it's this really understanding Kubernetes and what it's doing under the hood is very important, because they were literally taking out multiple nodes in a cluster at any given time, almost randomly to them. And they were blaming the product, which was making them want to move away from Kubernetes, when really it wasn't the product that was misbehaving. It was the person who wrote the CI job that did the wrong thing, because they didn't understand Kubernetes as a whole. So that's a long-winded way of saying, I think the disaster recovery thing is one thing, but the second thing is just not understanding how things work underneath the hood, where you think things are going to just magically work and you're never going to have a problem. You need to understand still core tenets of Linux to be safe in this kind of world, and to think through the implications of how things work ultimately at the end of the day. Like when it makes firewall changes, it's literally creating IP tables rules or firewall D rules to open up firewall ports and make things get port forwarded. If you don't understand that, then you don't understand the implication of when that happens frequently, how much compute power might be necessary for something like that, right? Anyways, so I know that was a long-winded way of answering the question.
No, that's interesting. Next one, what's something that industry leaders are doing now that's really giving them an edge?
The biggest thing I'd say is the people that are industry leaders is the fact that they had their training wheels off 3 or 4 years ago. They started playing with Kubernetes earlier. And so they understand the faults with Kubernetes before they went to production with a lot of their things. The industry leaders were not using Kubernetes without understanding it in production, is pretty much what it boils down to it. And now they've built the expertise around it. They're off to the races. There's a big learning curve for Kubernetes. And so the best way I would explain it is that they're able to approach things like API unification and this infrastructure agility type stuff without having to worry about not understanding the basic core tenets of Kubernetes, because their training wheels came off so long ago. They're running the Tour de France where everybody else is biking in their backyard while their dad's pushing them. You know what I mean? Like, so that's probably the best way I would put it.
So it sounds like for organizations that are sort of still evaluating Kubernetes or maybe earlier on in their journey, they've got to get a little bit of a wriggle on, because it just takes time to build that capability, that competence.
Yeah, 100%. If you're not, and it's more than just, oh, I took a training and I got my CKA. Like that's boilerplate. And I would say even having something like a CKA or a CKD is not necessarily necessary, but it's helpful to understand a lot of things. What's really important is you got to start getting your hands dirty with it.
Mm-hmm.
You have to.
And my last question, since there's no others in the chat, is what's an exciting new innovation, when it comes to Kubernetes that, is really going to make a big impact or have a big impact over the next 12, 24 months?
I think people, especially with the infrastructure agility thing I mentioned, I don't think people are understanding the value of Kubernetes virtualization yet. So for those on the phone who don't know what Kubernetes virtualization really is, if you're on premise, it's KVM orchestrated, kind of like Rev or Over, but those are going away, obviously. But when you're in the cloud, what it is it's abstracting away the cloud's VM creation process, so you don't have to talk to EC2 directly. You don't have to talk to Azure directly or GCP. What that means is if you were to build your entire business practice around doing everything in Kubernetes, and you only really, in terms of the cloud, had to just build enough expertise to stand up Kubernetes in the cloud properly and set the right security and network constraints and all that other stuff, you could completely unmarry yourself from a cloud provider in terms of virtual machines and containerized workloads. And that's way more powerful than I think people are understanding at this point, because once the infrastructure agility thing we talked about starts catching more wind, I really do think people are going to start building their entire business models around it, which is going to, for lack of a better phrase, cripple the market in a good way, in terms of cloud computing from a cost perspective. It's going to push Amazon, Google, Azure, what am I saying? What are they called? DigitalOcean, Oracle, IBM, all these big cloud providers. It's going to be a race to the bottom when it comes to how expensive your resources are. Because if you abstract away all the things that are the cloud and just use the Kubernetes API as your way to communicate with it, and then can move workloads between these environments, you no longer have to be worried about being married to the price of a given cloud. So now it's going to be who's the cheapest at any given moment. That's where I'm going to move to. And as that gets more and more vetted out and more streamlined, I think it's going to become a more aggressive play for a lot of companies. So that's where that's genuinely what I think is the case.
Yeah. Well, you wouldn't want to get left behind. Yeah. And I think if that does happen, then cloud computing really does become a commodity.
You're right.
And
that's the best way to put it, commodity.
And as customers or as organizations, it gives us a bit more power, a bit more flexibility, which can only be a good thing.
Yep.
Okay. Well, doesn't look like we have any other questions, so I think we can wrap up, unless there's anything that we haven't covered yet, Derek, that you really want to share with the audience here.
Not per se. The biggest thing that I think I want to harp on, though, is I know I talked a lot about things that probably make it seem even more overwhelming when you think about it, especially start talking about the assessment stuff. If you don't get started, you're gonna get left behind. And I don't mean that just career path wise, I mean that career path and company wise. At this point, especially with the infrastructure agility thing, and I know I keep hammering on that, but with KubeVirt and that whole play, I see Kubernetes growing way faster now. It's already started to pick up steam a lot in the last like 3 years, but I think it's really going to pick up an immense amount of steam now that this stuff is becoming more real. Because it's going to open the aperture lens of what the realm of possibility is for what you can do with it. And that's where I think people are going to go, okay, I mean, just think about it this way. It's not just about cloud providers. If I want to go back on premise, like if anyone has heard of the whole idea behind clawback, which is I moved into the cloud, it got too expensive. Well, what if you had a Kubernetes cluster in the cloud and a Kubernetes cluster on premise, and your clusters were linked up with things like kube slice and replication from storage with things like Portworx or Longhorn or something, right? And you just decided AWS got too expensive. And so in a matter of minutes, you could move your workloads on premise. And you wouldn't have to worry about refactoring, redeploying, any migration services, like it just does it automatically. I think that's where the world starts to change, because it's less about how can I be more efficient with Kubernetes? It's more about how can Kubernetes change the way we do business to not only scale more efficiently, but to reduce our costs in a way that we haven't seen before. That's kind of what I'm seeing for the future.
Exciting times ahead. Well, thanks, Derek. Appreciate you joining us. We will see you again next month when we look at another dimension of Kubernetes, which is security, which is one of your favorites, I think, right?
In certain ways, yeah. Otherwise, no. Yeah.
Alrighty, well, to the audience, thanks for joining us. We will make this recording available if you want to rewatch it or share it with your friends. And we'll look forward to seeing you next month. Thanks, Derek.
Yep. Thank you.